Hello everybody, welcome to Top G Tutors YouTube channel. I'm Murat, your AP Computer Science teacher, and it is the first video from AP ComputerScienceA course. Today we are mastering Java strings, the text behind emails, usernames, and search boxes. If you've ever typed anything into a computer, you worked with strings. And here is the promise for the next 15 minutes. By the end, you will use the AP tested methods with confidence, avoid the classic mistakes that cost 80 points, and solve exam-style puzzles without any stress. I will keep the pace friendly, ask you a few checking questions, and explain every answer we get. Sound good? Let's get started. First of all, we'll talk about what a string is in Java, then about concatenation. After that, I will explain you the AP tested methods, the traps the students fall into and how to dodge them, and in the end we will have a guided quiz with explanations so the really sticks. Warm-up thought. If I write string s equals hello and then change it, did I actually modify the original string? Keep that question in mind. We'll answer it in 1 minute. What is a string? In Java, a string is an object, not a primitive. That means it's a reference type. Variables hold references to objects in memory instead of the raw text. Imagine each object as a labeled box. Your variable is a sticky note pointing at that box. Now the most important property. Strings are immutable. Once a particular string object is created, say hello, that object never changes. When you modify a string, Java actually creates a new string object, and the variable points to that new object. Quick demo. Hello didn't mutate there. Java created hello and moved s to the new box. Why this matters on AP? Firstly, comparison. Double equals compares references. Equals method compares contents. And secondly, efficiency. Repeated plus in loops creates lots of new objects. Later, we'll pick at string builder. One more note, Unicode. Java stores text using Unicode, so not every visible character maps one-to-one to a char. For AP CSA, you usually treat characters as chars and indices as positions in that char array. Just know why emojis can behave oddly outside the exam context. Quick check for later. If string A is equal to high, string B is equal to new string high, what do a double equals B and A dot equals B print? Hold that, coming soon. Before we dive into the official AP methods, let's cover the tool you will use constantly, concatenation. This is where many small surprises live. In Java, the plus operator concatenates strings when at least one operand is a string. The result is a new string because strings are immutable. Plus equals is just syntactic sugar. Plus equals means take the old value, append, then reassign. It still creates a new string. Very important left-to-right evaluation. Plus is left associative. Java evaluates from left to right. As soon as a string appears on the left, everything to the right is treated as text and concatenated. Rule of thumb. The first time a string shows up on the left, you're in a glue mode. Everything after gets glued as text. Numbers, chars, and weird results. A is a char, a small integer code. If no strings is involved yet, Java does arithmetic. But if a string is already on the left, Java switches to text. Concatenating null. If one operand is a string and the other is null, Java uses strings value of null. Not an error, just surprising during debugging. If you see null in your output, a variable likely wasn't initialized as you expected. Performance. In big loops, repeated plus is slow, because each step creates a new string. That's why we have string builder. This isn't an AP CSA grading focus, but it's good software engineering. Mini quiz. I recommend you to stop the video and solve these 5 examples. Then I will show the results with explanation. Okay, here are the answers. If you have any questions, write them in the comments. Let's move on. The APCSA quick reference highlights a short list of string methods. Master this, and you are ready for most string questions. We'll go one by one with patterns and edge cases. Firstly, length. It returns the number of chars in the string. In this example, system will print 10. Remember, last index equals length minus 1, zero-based indexing. Guiding question. If s length is 5, which indices are valid? The answer is in 3, 2, 1. Of course, it's from 0 to 4. Secondly, substring start or substring start, comma, and method. It returns a new string that is a substring of this string. Yeah, so many string words. The first and the second have the difference. First starts with character at start index and extends to the end of the string. Second starts at start index and extends to character at end index minus 1. Think of it this way. Start index is the first character that you want. End index is the first character that you don't want. The method throws a string index out of bound exception if start index is negative, start index or end index is larger than the length of the string, or start index is larger than end index. However, the AP Java subset lists only index out of bounds exception, which is what they will use on the AP exam. Valid bounds: 0 less than or equal to start, start less than or equal to end, and less than or equal to length. Here is the examples on your screen. As you see, the first one prints the chars from 0 to 3 minus 1, and the second one prints from index 3 to the end of the string. Useful patterns. We can find the first char by the s.substring 0, 1, last char by s.substring s.length minus 1, all but first by s.substring 1. All but last by s.substring 0, s.length minus 1. Mini challenge. How do you think what will be the result of this expression? Answer will be in counts. The third method is indexOf string str or indexOf with parameters string str and int from index. Returns the index of the first occurrence or minus 1 if not found. Case sensitive. The method throws a null pointer exception if str is null. In this example, you can see that it gave us the index of the first char. Asset search. When we used this method without from index value, it gave us the value of first a. But when we search starting with index 2, it gave out 3 that the index of second a. And two comparison methods. Equals and compareTo. Equals string other string is used for content equality. It returns true if first string and second string are identical strings, false otherwise. We can say it compares the characters of two strings one by one to check if the text is the same. For instance, here the answer is true because the sequence of characters inside these two strings is the same. Be aware that Java is case sensitive. Thus, if s1 is cat and s2 is cat with a capital letter, s1 dot equals s2 will return false. Compare two string other string compares strings in dictionary lexicographical order. If string 1 dot compare to string 2 less than 0, then string 1 precedes string 2 in the dictionary. If string 1 dot compare to string 2 more than 0, then string 1 follows string 2 in the dictionary. If string 1 dot compare to string 2 double equals 0, then string 1 and string 2 are identical. This test is an alternative to string 1 dot equals string 2. Not required by the AP Quick Reference, but common in real projects. To lowercase to uppercase for case insensitive checks, trim to remove leading trailing spaces. We'll avoid relying on them in AP style solutions today, but you can read about them in my Facebook account. Link in the description. Let's move on to 6 classic pitfalls. First, using double equals instead of equals method. The expression if string 1 double equals string 2 tests whether string 1 and string 2 are the same reference. It doesn't test the actual strings. Using double equals to compare strings may lead to unexpected results. For example, here the test returns true even though it appears that S and T are different references. The reason is that for efficiency, Java makes only one string objects for equivalent string literals. This is safe in that a string cannot be altered. But then the test returns false because use of new creates a new object and S and T are different references in this example. How to fix? Use equals for content. Remember, double equals is about same box. Equals method is about same writing. Second pitfall. Off by 1 with substring. Here the code will crash because and more than length. How to fix? Enforce 0 less than or equals to start, less than or equals to end, less than or equals to length. And use substring start to go to the end safely if we don't have end index. Pitfall 3. Confusing length with last index. This code will give an error because index 3 out of range. Always remember that index is length -1. Pitfall 4. Ignoring -1 from indexOf. It will crash because there is no x in banana word and p is equal to -1. That's why substring method will cause string index out of bounds exception. Pitfall 5. Case sensitivity surprises. System will print -1 and same will be equal to false because a capital J is not the same as minor j. How to fix? In AP style, compare exactly as given unless the problem states otherwise. Normalize case first if we talk about real projects. And the last, 6th pitfall is inefficient plus in big loops. Repeated plus creates many temporary strings. Prefer string builder in large loops. It's about awareness, not an AP penalty. Now the promised quiz. I will show the code, pause, then explain. You can stop the video if you don't have time to solve the task. Question 1. The answer is BCD. We start with index 1, element which is B, and end with 4 minus 1 index element which is D. Question 2. Answer is -1 because case matters. Question 3. The answer is false, then true, because references versus contents. Question 4. The answer is positive because T more than R in the ASCII chart. Question 5. The answer is banana. P is equal to -1, so -1 plus +1 is equal to 0. But it is not safe, because must check for -1 first. Question 6. The answer is true, because both conditions satisfied. Question 7. The answer is APCSA because and equals length is allowed. Question 8. The answer is false. Safe to call on the literal. Debugging mindset for strings. When something feels off, walk this checklist and ask yourself the following questions. Firstly, indices. Did I use length as an index? If yes, that's out of range except as the exclusive and in substring. Secondly, bounds. For substring start, end, ask whether 0 less than or equal to start, less than or equal to end, less than or equal to length. Thirdly, search. Did indexOf return -1? Did I check before slicing? Fourth, comparison. Did I accidentally use double equals instead of equals method? Fifth case. Is the problem case sensitive? On AP, often yes. And sixth, empty string. What happens with empty string? Any of by one risks? I've compiled a mini practice for you that will help you better understand how to work with strings. The solutions will be in comments. Let's summarize the results. Today we learned string is a reference type and immutable. Modifying creates a new object. Concatenation rules. Left to right evaluation, glue mode after the first string, char arithmetic without a string and null becomes null. AP tested methods and when to use them. Length, substring start, comma and indexOf equals and compareTo. Pitfalls to avoid. Double equals versus equals, off by one indices, forgetting -1, assuming case insensitivity and heavy plus in big loops. And you solved quiz prompts with full explanations. So the reasoning, not just the answer, is yours now. So you've got this. Our lesson has come to an end. If you'd like to go deeper and practice with me directly, you can sign up for the trial lesson on our website or just message me on Facebook. The links are right down in the description. And don't forget, subscribe, hit that like button if this video helped you, and drop a comment. I read every single one and I'd love to hear your thoughts. See you in the next lesson. Bye bye.